Hey guys, welcome to section 4.5. So let's just get right into it. Where I want to start actually is I want to get you warmed up for this. It's been just a little while since we solved an equation. Pause the video and just solve the two equations that you see here and hit play when you're ready. Okay, so for this first one, so I'm going to take 3x plus 15 equals x plus 9, and then I'll subtract off the x's. So I get 2x plus 15 equals 9, and then I will subtract off the 15. So I get 2x equals -6, and if I divide both sides by 2, my final answer will be x equals -3. Now for the other one. This will be 6x minus 15 plus 20 minus 12x equals 4 minus 6x. Double check all your signs on that. So now this will become 5, just 5, sorry, minus 6x equals 4 minus 6x. Now, there's a couple different ways that you could have done this, but I'm going to work on getting the x's on both sides, and that will kind of get me to the point of this one. So when you do this, notice you have negative 6x plus 6x, so actually they drop out on each side. So you're just left with 5 equals 4. What's the interpretation of this? The interpretation of this is that there is no solution. Okay, so I just wanted to refresh your memory of kind of all of that because we're going to be doing sort of like that with this section. So what we're going to be talking about today are systems of equations. So a system of equation refers to two or more equations that share two or more variables. And we're going to start by looking at a solution of a system of equations. So a solution is a ordered pair that is true in all equations. So I'll just show you what this means. So here in example 2, so what I want you to do, just to get used to this, is I'm going to give you an ordered pair, and basically I just want you to plug it into both equations. So you have to plug it into both equations to make sure that it's true. So let's do the first one together. So I've got x minus 2 times 3 equals -5. So this becomes 1 minus 6 equals -5, and yes it does. So we're good there. So the first one works. So now I have to plug this into the second equation. So now this will be 2 times 1 minus 3 times 3. So does that equal -4? Let's see. So this will be 2 minus 9. So does that equal -4? So it does not, right? This actually gives us -7 equals -4. So this is not a solution. So no, this is not a solution. So this is kind of why you have to be careful when you do this. This actually illustrates the perfect point that you need to just be aware of. You could have that solution work in one equation but not the other, and if it doesn't work in both, then it's not a solution. So let's do this again for the other one. So I'm going to plug in -4, 3. So I've got -4 plus 3 times 3, does that equal 5? So that's -4 plus 9. So that definitely equals 5, so we're good to go there. And now 2 times -4 plus 3 times 3, so I'm plugging this into the second equation. Does that equal 1? So this is -8 plus 9. Yep, that definitely equals 1. So this would be a yes. This is a solution. So this is good to note because you're going to want to check your solutions in both equations every single time you do this, just to make sure that you found the right solution. So this is what a system looks like. You've got these two equations. This is what the solution looks like. It will be an ordered pair. And now what we're going to do is we're going to discuss a few ways to actually solve these. So the first method is actually solving by graphing, which we've already been graphing in this section, so that's why this kind of lines up together pretty well. And it's actually a very simple approach. So all you're going to do is you're going to graph both lines. So what I'm going to do to graph this first line is I'm going to graph it in orange just so you can tell which line it is. So notice that this equation is in slope-intercept form. So my y-intercept is 3 and my slope is 2. Okay, so let's start with the y-intercept. So I've got to go to the 3, so I go on the y-axis and I go 1, 2, 3. So there's my y-intercept. And now I count out using my slope. So I go up 1, 2, and over 1. And build it again, up 1, 2, over 1. Okay, so there's my solution. And actually, I want to even add in just a few more points, so I'm actually going to go in the reverse direction. just to make sure my line is nice and precise for this exercise. Okay, so there was the first one. So now let's go to the next equation. So I'll use this blue color here. So I've got y equals negative 1/2 x minus 2. So now my y-intercept is negative 2. So I'm going to come down to negative 2, 1, 2. And then I'm going to count down 1 over 2. And I'm going to reverse that. So I'm just going to get a couple points going in each direction. So I'll connect those points. And now I can make my point here. So the solution of a system is just found by the intersection of the two equations. So that's probably not surprising, actually, because that's kind of the approach that we've used for finding the solution to just general equations. So if I have two equations together, actually now, it's basically like these are both y equals. So it's almost like solving 2x plus 3 equals negative 1/2 x minus 2. So this is really just an extension of something we've already been doing this semester, but now we're just giving it kind of a new name. So here's where my solution is. So what is this point? This point is the point negative 2, negative 1. So that's the solution. Now, just to be thorough, I want to check it. So I'm going to plug in this into both equations. So let's see, I've got negative 1 equals 2 times negative 2 plus 3. So let's work that out. So that's negative 1 minus 4 plus equals negative 1 equals negative 4 plus 3. So that definitely works. And now I'm going to plug the solution into the second equation. So I get negative 1 equals negative 1/2 times negative 2 minus 2, not minus 1. And so then this is negative 1 equals positive 1 minus 2. So yes, that checks out. So that's how you can be sure that you got the right solution. So now what I want you to do, I actually want you to pause the video here, and I want you to try this at your own pace for these two examples. Hit play when you're ready to see the solution. Okay, so starting with the first one, so I'm going to use the orange color again. So my y-intercept is 1, so here I am at 1. And then to get to the next points, so I'm going to go down 1, 2, 3, and over 1. And I personally just like to draw out a few points going in each direction, because then that helps to make sure I can really clearly tell where that point of intersection is. So that's why I keep drawing multiple points and going in both directions. So now for the other one, I'll use this blue color. So my y-intercept is negative 4, so I come down 1, 2, 3, 4. And then I'm going to go up 1, 2, and over 1. And now I can already see my point of intersection, so I'm good to go. Okay, so my point of intersection is right here in this case. And so in this case, my solution will be, let's see, this looks like 1, negative 2. Is that what you got? Well, I hope so, because that's what I got, and I know that's the right solution. Okay, so let's try the other one. So notice there's a little bit of a plot twist with this one, in that these are not in slope-intercept form, so hopefully you notice that. There's a little bit of a plot twist, just got to keep you on your toes. So for this, I first want to probably put it in slope-intercept form, but that's easy enough to do, right? I can just bring the x over to the other side. So just to be nice and explicit here, so here's what I've got. So I'm just going to add the 1/2 to each side. So I get y equals 1/2 x minus 4. There's my first equation. And then let me do the other one. So I've got this y plus 2x equals 1. So I'm going to subtract off the 2x. And y equals negative 2x plus 1. Okay, so now that's what I've got to graph. So I'm going to graph this first one in orange. So now I'm going to go down 1, 2, 3, 4. There's my first point. I go up 1 over 2. I'll just do this a few times just to kind of make sure I got a bunch of points. Okay, so there's my line. And now let me do the other one. So I'll use this color. So here the y-intercept is 1. And then I'm going to go down 2 over 1. Down 2 over 1. Okay, so I've got that. And okay, there's my line. Okay. And so my point of intersection is right here. So what is that point? That point looks like 2, negative 3. And so you can check that solution on your own, but that's kind of the idea. So I have just one other kind of situation I want to talk about now. What happens when you have no solution or infinite solution? So this will come up quite often, and it will look, you won't really be able to tell at first. But notice the first equation here is already in slope-intercept form and the second one is not. So the first thing I want you to do is just put this second equation in slope-intercept form. Hit play when you've done that. Okay, so I've got 9x plus 3y equals 6. So I'm going to go ahead and solve this for y. So I've got 3y equals negative 9x plus 6. Divide everything by 3, so I've got y equals negative 3x plus 2. Okay, now wait. Do you notice anything? This and this, they are the same thing, right? Now, here's the deal. You still actually want to just think about what happens when you graph both of these, and honestly, you probably already know the solution to this. So if I graph the first one in orange, so let's see, I go up to 2, and then I go down 1, 2, 3 over 1. There's my first line, right? And now if I draw the other one, so now I'll use this blue color here, it's going to be the same line, right? So it almost feels silly in some ways. So it's always overlapping. So you guys already know the interpretation of this, right? This would be infinite solution. Now I can hear the question already. It's, do I still have to graph it if I notice that they're both the same line? So if we're trying to approach this from a graphical standpoint, then yes, you do have to actually go ahead and graph it. And hey, if it's the same line, then you just copy over the other one, right? So that's not so bad. Okay, so what about this other one? So same thing, right? So we've got to solve for the second equation. So maybe pause, hit play, see if you can figure out what the two lines look like. See if you can actually finish the whole thing. Hit play when you're ready. So I have to do the same thing. So I've got 2x plus 4y equals 12. So I need to solve for y first. So I'm going to do that. So I've got 4y equals negative 2x plus 12. Divide all sides by 4. So I get y equals, now this will come out to negative 1/2 x plus 3. Now if I compare this to this, they're not the same equation, but you can tell by looking at the slopes that they're going to be parallel, right? So we already kind of know what the solution is going to be, but let's graph it. So let's see, this first one's going to have a slope-intercept, or the y-intercept is 4. I go down 1 over 2. And I know they're not going to intersect anyway, so I'm not going to draw too many points. And then for this other one, so I'll use my blue color again. Now I'll go up to 3. Do the same thing, down 1 over 2. Bada bing, bada boom. We're good to go. Okay, and so now you can see definitely they don't intersect. We even know they're not going to intersect because we know that they're parallel, because we know stuff about parallel lines. So here we'd say there's no solution. Done. Or you could use the empty set notation if you like. Okay, so that seems actually like a good place to pause. So we'll pause here and I'll see you guys in the next video.